Hi everyone and welcome to the channel, and today we're going to be looking at something like this, which is actually a parametric wall art, and learning how to create a spreadsheet that controls cross sections. So we've got this, which is basically a standard loft. So if we come into the common, we can see we've got a loft here, and this loft, as you can see, is controlled via the spreadsheet. So I can change any of these in the spreadsheet. So set this one to 10, set this one to 30. We'll set this one to 30 as well. And what will happen when we look at the loft, we can see that's changed in there. So when that changes, this will also change the cross sections going through. And this is all to do with compound objects. So we're going to learn about compound objects, what they are, and how to create them. Once we've got this, in the next video, we're going to learn how to use the Lattice 2 workbench, which will allow us to take these and reset the placements of them, like so. So what's happened here is we've taken all of the childs of that compound and placed them along one plane to allow us to take these and extrude them and laser cut them or CNC them. We can also reset the placement. So for instance, if I come in and have a look at these, I'll find that I've extruded these as well. That's fine, the other extrude. And I can take all of these and reset the placement. So I've stacked them together, and this allows me to export these one by one to an STL file or a step file. That may take some time, so in video 3 we actually look at a macro that I've created that we can actually export all of these by just selecting them. So shift select them, control select them, and we can export those into individual files just with one single click of the macro. So you can see here we have the individual files that are sitting in here. So I hope you're enjoying these videos, and let's have a look at this workflow. If you like what you see and you want to donate to the channel, then you can do so via Ko-Fi or Ko-Fi at ko-fi.com/MANG0, or via PayPal at paypal.com/paypalme/DarrenBEstone. I also run a Patreon where you can get early access and additional content, and that's at patreon.com/MangoJellySolutions. Links can be found in the channel header, on the About page, or in the descriptions of these videos. So we've created a new document in FreeCAD, and I'm going to be using a part workflow. Now, I could use a part design, but I want to use tools in here for splitting and booting the end product, so it'd be easier to do it in the part workbench. First of all, we need the sketch. And let's go up to view and toggle axis cross. So I'm going to create the sketch along the XZ plane. So new sketch along the XZ plane and hit OK. This is going to be our first sketch of our loft. So we're going to use a loft workflow to create the surface. If you come over to the left, you can see if I drop down inside the constraints here, we open that up and drop down this little icon here, the settings. You see we've got the auto constraints and the auto remove redundants. So I can auto constrain to these axes here and any of the other geometry. I'm going to start with a polyline going across here. So let's click on the polyline, create a polyline, and hover over to the center point. You can see that we've got coincident constraint. I'm going to go along this axis and connect up to this axis. And you can see we're connecting up with 5 points going along that axis there. Hit escape again to get the mouse pointer back. So we've got those there. Let's make all of these. So click all of these. I'm not holding down shift. I'm just selecting each of these, adding them to something called the Hungary selection. So we've got those selected in there, and make those equal. So we have these lines in here. Next thing I want to do is set some length in here. So taking these 2 points and set a length. And we'll set a length, say 200 millimeters. So we've got our first length in here. Now we're going to create a height with a single line from this point coincident to the center point and up, attaching to this axis. Again, let's set some length in here, clicking on that and using a vertical length of 50 millimeters. Now we've got these in here, we can see them. Let's add a number of points to go along here. So these points will allow us to connect up to that B-spline and also use constraints against the B-spline. And use the point. I'm going to place a point going across this way. So we're going to place 4 points going across here. Let's hit escape and we'll use this point and use the vertical constraint that keeps them in line. We repeat with all the other points. So what we'll end up with is that these points, let's do it the other way. So let's use the vertical and click this one and then this one and then go this way. A lot quicker. So what we'll end up with is these evenly placed across the horizontal. Hit escape to get the mouse pointer back. So we've got these in here. So now let's name these constraints. So this one here, I'm going to call this point 0. So this is the starting point of our curve. A B-spline will connect all these up. So this point 0, this one here, that sets some height between here and here, and you can see why we need this polyline now. Height, and this one's going to be point 1. This one is point 2. This one, bring this up a bit, is going to be point 3. And finally, this one is going to be point 4. Point 0, 1, 2, 3, 4. I set this one here just to length and OK that. So we've got 9 constraints in here. So what I'm going to do now to make it easier, I'm going to come into here and just click on the I button and hide all those constraints in there. Now, if we look up at the top, we've got the create B-spline. Let's click on that, hover over the first point, this one here, come over, hover over the second point, click for coincident, and repeat going across all the points. And finally, when we get to the last point, we need to hit escape or right mouse button, and we get our line in there. So we got our B-spline going across there. Because I'd named those constraints, I can hit close and we can see the sketch there. Also need a length here, which we'll add in a moment. And I can click on the sketch, come down to the data tab, and we see all the constraints in here. So I can set like point 1 to 20 and point 2. Let's say this one is 10. And we can control that line in there quite easily. Let's come in and finish off our sketch. So I'm going to place a line that connects up this point with the top point here, coincident to that, and we finally got that line in there. Let's close that and see what we have. So we have this shape. So the sketch here, I'm going to right click, rename, and I'm going to call this profile 0. So this is the first profile that we're going to use. I'm now going to create a spreadsheet. So I'm going to come up to the drop down at the top and come over to the spreadsheet workbench. We're going to control these constraints via a spreadsheet. So let's create the spreadsheet, come up to spreadsheet, create spreadsheet, and in here I'm going to start adding some headers. So this is the first sketch, which is profile 0. And in here we have 0.0, 0.1, 2, 3, and I believe it went all the way out to 0.4. So we've got all those points within there. We have a length as well. This is going to be an overall length for all of them. So we may need to add that in as well. Let's add that in, say somewhere down here. So length. This one's going to be the value, which we're doing in millimeters. And what I'm going to do is alias these up. So the alias here, what I'm going to do is just take a copy of this and place, clicking on this cell and place the alias in here. So 0.0, making sure that we haven't picked up any commas or anything on the front. So 0.0 in there. Hit enter. And we click off. So this one here is going to be 0.1. And this one is 0.2. And we carry on down. 0.3. And this one is 0.4. And you can see that we've done it correctly because as we click off, we get these colored in a light yellow. This one we're set to length. So we've got all those aliased up. So we've got the values here. So what I want to do is pull the values from the spreadsheet. So 0.0 is going to be 200, and we just add some random values in here. 50, 10. Let's set this one to 30, and this one to 50. The length was 200, so we'll set that as well, 200 in there. Now we've got these spreadsheet values in. I want to reflect those in the constraints. Now I'm going to have multiple sketches. So this is just profile 0. So at the moment we have got 0.0. So I may want to add some kind of X in here to denote the profile that we're looking at. So we can edit these by coming up, and let's say we edit this to be 0.0_1 and hit enter. So that has changed. So we can change those if we want. Let's just delete that and show you how this can be changed when we've already added it to the sketch. So we've got 0.0 here. Come back to profile 0 and double click it. So the first one here, we need to show all these constraints. We want this one here, and we want to set the length via the expression, little icon on the end. And we set this to spreadsheet. Click on there, dot, and we should have a 0.0 in here. So we've got spreadsheet 0.0. Let's OK that. So our name is 0.0 and we've got the length in there. Let's hit OK. And that sets that to 200 millimeters. So if we close, we can see on the spreadsheet, the 0.0 is 200. A bit too much. Let's set that to 20. And we'll know that when we set that, that will change. Let's double click the spreadsheet. So we've got to do 0.1, 2, 3, and 4. Back over to the sketch, double click the sketch, and we'll work our way through these. So this one, so expression, spreadsheet dot 0.1, and OK. And it's just a case of repeating it on each of these points. So each of those constraints, select in and 0.2. We can copy this to make it easier. Control C that, OK, OK that one, and double click this one. Paste that in, change it to 0.3, OK that, and OK. And this one, click on the expression, and this is 0.4. OK that. And this one here is the length. So we need the expression, spreadsheet dot length. It's 200, and okay that. So now we set up our spreadsheet. You notice that all the constraints have been made orange. So this means that it has an external reference. The constraint goes into an external source. Let's close that. So that's our spreadsheet and the profile set up. Let's save this. So I saved it as wall art. And now what we can do is take this profile, edit, duplicate selection. Don't want to duplicate the spreadsheet. Let's untick that. We just want to duplicate the profile 0. Let's OK that. We now got a profile 001. Right click, rename. Let's take the 0 off. Profile 1. If we look at that, we got the constraints and it's all set up to 0, 1, 2, and 3, which we don't want. But first of all, what I want to do is place this. Let's click on the profile and look at the placement. So we've got this placement here. Again, we could drive this from the spreadsheet. So we've got the length here, something called section distance. And we can set that in here. So we'll set this to something like 50 and click off. Let's copy that header, click on the value and set the alias. Make sure we haven't got any special characters in there. So section distance. So we set that one up. So let's click on our first profile, this one here, and come into the placement, the position. We're looking along the y-axis. This y-axis here, if we increase this, it's going to move along that y-axis. So again, click on the little button on the end of the expression and type in here spreadsheet dot section distance, and each section we're going to times it by whatever it is. So this one's going to be times by 1, so we don't really need that. Next one will be times by 2, etc. So spreadsheet dot section distance. Hit enter and hit OK. When we click off, that will move that across there. So now we've created a copy of the profile. We need to modify the spreadsheet to have a group for that profile. So a group of these settings, because at the moment this profile, if we look at the constraints, it's still set up to 0, 1, 2, and 3. So to do that, we first need to make a copy of these. So we take those, edit, copy, come over to, let's say, column D, edit, and paste. So we've got those in there, but the aliases haven't come across because, well, these are unique. So we need to create a unique alias for profile, and let's rename this to profile 1. So at the moment, we've got the alias of this one as 0. I'm going to come in and put an underscore 0 on all of these. So there's 0.1 underscore 0 because this is for profile 0. And I'm going to do this for all of them. Now, one thing that you will notice is that we're not going into error in our tree view. So over here. And this is because that even if we change the alias, if we look back at the profile, you can see we've got a 0 underscore 0 now. So this is updated as well when we change that alias name. Profile 1, obviously, because it's a copy, we've still got this updating as well. So let's come back and we need to alias up these. So this is going to be 0 underscore 1. And I'm going to Control C, and with all of these come in Control V, and this will be 0.1. This one will be 0.2. And so on. And the last one is 0.4. So now if I list these up, let's come over to profile 1 and change all of these. So if we look on here, we've got the length, which we don't need to change, but we do need to change all of the formulas. So these are all 1 now. Okay. This means that we can change the settings of each of the profiles for each of the points independently of each other. Now we're going to need at least 3 profiles, because if I create a loft against these two, it will be just a ruled surface. Because there's no curvature, we'll be able to draw a straight line to these points, which is not what we want. So now we've updated profile 1, we need to create a copy of this again and repeat the process. So duplicate selection, uncheck the spreadsheet, hit OK, and rename this one to profile 2. Again, we need to take the spreadsheets and create a copy of these, edit copy or Control C, and paste them in a new cell, and then change the aliasing for each of these. So this one here is 0.0_1, and this is going to be profile 2. So this one is going to be 0.0_2, and carry on down. Once our spreadsheet's complete, let's come over to profile 2. Come in, and we need to change the distance, so we can see the spreadsheet distance here. Let's change that and times by 2. So we've got that one in there. And then we need to come down to the constraints, and we need to change these and change them all to 0_2. This one _2, 0.1_2, and carry on down. Once we've finished, what we should have is a spreadsheet that will control these profiles. So we can come into the spreadsheet and change, say 0.0 to be different values to what it was before. And we can see that change has taken effect there. So we'll create our profiles. The next thing to do is loft through these. So now we've got our 3 profiles. We can loft through these. So let's come over to the part, and we're going to create a loft. We'll come up to part and loft. We add the profiles in order, so it'll be 0, 1, then 2. Just double click them and move them over, and you can see them being added in order. Last profile. Make sure the create solid is selected and the ruled surface is not selected, and hit OK. And we get a loft going all the way through those profiles. If you forget to set the solid to true, then we can set it after clicking on the loft and set it down here. Remember, we can change the loft or the look of the loft from within our spreadsheet as well. So if we're not happy with the design, we can come in and change this. And that will take effect. So once you're happy and we've got everything that we want, we can start making the cross sections through here. To do that, I'm going to hide the loft and come in and also shift select all the profiles and hide those as well by pressing the space bar. So everything's hidden. Let's come over to the sketcher and make a sketch along the XZ plane. So new sketch along the XZ and hit OK. If I go back to the model and have a look at the loft and bring back only one of the profiles by clicking on it and pressing the spacebar, we can see where that sits. I'm going to create a single line and connect up to the center point and bring this out this way, making sure we've got the horizontal constraint kicking in and it sits there. So we've got our line. Let's click on the line and place some distance along here. Now the distance I'm going to use the formula and type in here spreadsheet, and then we want the length, and hit OK, and OK that. So we've got the length, which will be the same as our loft. Now we've added that, I'm going to create an array of these lines going this way. To do that, I'm going to exit the sketcher, clicking on task, hit close, and I'm going to hide that profile of that loft, so just have the line. Let's use the draft workbench, and in here it has a number of arraying tools. I'm going to turn the grid off and come up to view, toggle axis cross, so we can see where the axis is. Click on that sketch, come up to the modification, and we're looking for the array tools, and we'll click on array. We want to array along the Y, so we want only one along the X. Let's go for something like 8 along the Y. The X intervals, well, we don't need that, so let's zero that out, 0.0. So let's go on the Y intervals and have a look at that. So we've got 100 millimeters there. We'll set this to 5 mil. The Z, again, we don't need that. We can zero that out. Let's come up and hit OK. What we get is a series of lines, and now we can edit that array. If we bring back the loft by clicking on it and pressing the spacebar, we can see that we've created those lines, and they sit on the bottom of that loft. We need to span the length of this loft because this is going to be our cutting tool to make the cross sections. There is a cross sections tool in the part workbench, but it's not parametric. So let's come over to the array, click on the array, and come back down to the interval Y, this one here. So this Y setting, we're going to use the formula on the end and set that to spreadsheet dot selection distance, and we want to times that by 2 because we have those 3 profiles that span over a 100 millimeter distance. So we use this in our last profile if we remember. So if we had 4 profiles in here, that would be times 3. Let's bracket this off, and we're going to divide this whole lot. So just put brackets around here just to distinguish what we're doing. We want to divide that by the count. So we can see this count in here at the moment is 8. So type in count, click on that and hit OK. And what should happen when we click off? It spans the whole lot, but it hasn't spanned the end. So let's come back into the array. Let's click on that array and just alter the formula. And we'll place count in brackets and place a -1 in there and close the brackets. So what we should get now is that will span the whole of the bottom section. Now we've got the array, what we can do is extrude this. So let's come over to the part workbench and use the extrude. We need to extrude along the Z axis, so going straight up here. So make sure we extrude along the Z, and this will be in the positive direction. So this way is positive, this way is negative. If we're just going from the center point, so positive, negative, positive, and negative if it's going along the X. So positive Z, and we're going to go, let's say around about 200 millimeters and hit enter. What we get if we look from the side, we get a number of cross sections. Let's reduce that extrude. Let's say about 100. There we go. So we've got the cross sections going through there. So we extruded the array with basically single faces. What we can do now is select the loft, control select the extrude, and create a common or an intersection against those. So part, boolean, and intersection. And we get all the profiles for our parametric wall art. And at any time we can come into the spreadsheet and change these. So for instance, let's change this to 20, this one to 5, 0.2 to 30, and then when we come back, those have recomputed and they've all changed in there. To make this work faster, because each time we change something in the spreadsheet, what I can do is click on the wall art project, right click, and come down to skip recomputes. Therefore, click on the spreadsheet and start changing these values in here. So I'm going to set this one to 40, and you'll notice how much quicker this is now. So 30 and 20. We'll set this one to 5, this one to 20, and then we'll click back onto the common. You can see there's a tick on the spreadsheet, which means it needs to come up to edit and refresh, and this recomputes. So we get our shape going across there. Let's set up the number of cross sections we want in the spreadsheet. So click on the spreadsheet, and we'll come in and type in cross sections. Place a value in here, I say 10. Notice this is in blue. This is because it hasn't recomputed yet. Let's click on that and type in an alias of cross sections. And come back to the common, drill into the common. So in here we'll have the extrude and we'll have the array. This one here, let's press the space bar so we can see that array in there. Click on the array and we'll come down, not the count, because this is read only. Let's come down to the number Y, this number here, and use the formula in here. So I'm going to click on the formula editor and type in spreadsheet and type in cross sections. Now you can see that it's not coming up. So that's clear. And click on the spreadsheet, right click and recompute object. Notice this has gone black now. So if we come into the array, we should be able to go to the number and find that in our spreadsheet. So spreadsheet dot cross sections. So always remember, if we got the recomputes off, then even if the spreadsheet changes, we have to right click refresh if we're going to use the formula. Let's click off. So the array hasn't updated yet. Edit, refresh, and we get those cross sections in there. But we have more lines than our common. So why is that? Let's have a look at the array and see what's going on. So the count has changed. The extrude has changed. The loft, as you can see, this is further. So click on the array and have a look. Let's come into the Y interval. And you can see the Y on here hasn't updated. This one here is saying 14.29 still. Let's come into the formula. And the minute we come into the formula, you can see this has changed. So let's change the count -1 to look at the spreadsheet and the cross sections. And hit OK. Let's click off. As you can see, we've got more cross sections going across for that loft. Edit, refresh, and you can see we now have got all those in there. Let's come up to the wall art, right click and skip recomputes. Let's uncheck that and see if that's fixed the issue. So cross sections of 10, let's set this to 15 and click off. Back to the wall art, and we can see that's working now. So when we've got values in the spreadsheets and we're using that in the formula, then it's worth taking it straight from the spreadsheet rather than taking it from something like the count, which could result in a recomputation problem with these. So now we've got the extrude, let's press the spacebar, and the array, press the spacebar on that. We have these cross sections that we need to flatten out so we can laser cut these or CNC these. So in our next video, we'll do just that. We'll take the parametric cross sections and then use something called the Lattice 2 workbench to flatten them out all along one plane, while still keeping the parametric capabilities, allowing us to edit the spreadsheet and for these to update accordingly. As well as that, we'll be able to take all of these and place them in one stack, ready to export the individual items into separate STL files or step files, whichever format that you want to export these in. We can alter that placement whenever we want, just by changing one single variable. So a link to that video is in the description, and also I'll place a link up on screen now. Hope you enjoyed that video, and I hope to see you again soon. If you like what you see and you want to donate to the channel, then you can do so via Ko-Fi or Ko-Fi at ko-fi.com/MANG0, or via PayPal at paypal.com/paypalme/DarrenBEstone. I also run a Patreon where you can get early access and additional content, and that's at patreon.com/MangoJellySolutions. Links can be found in the channel header, on the About page, or in the descriptions of these videos. I thank everybody that's donated so far. It really helps to keep the lights on so I can produce more content and also expand the channel. Thank you for liking, commenting and subscribing to these videos, and I hope to see you again in the next one.